Imagine your team just completely finished building a new AI product. The system executes its tasks seamlessly. The front end talks to the back end, the AI responds exactly as it should, and the database stores every result without a single error. Then you release it, and almost nobody actually wants to use it. This creates a difficult situation for the development team. A project can be a complete technical success and an absolute product failure at the same time. Proving that a complex system works technically provides zero evidence that the product creates actual market value. Avoiding this type of failure requires teams to gather evidence and learn before committing to a massive build. The kind of evidence you need depends on where your project is most vulnerable. You must seek out two distinct information streams. This matrix shows two specialized frameworks to gather that information. Minimum Viable Product, or MVP, addresses market risk, while Tracer Bullet Development addresses technical risk. Both function as specialized diagnostic tools, built to investigate entirely different project vulnerabilities. Choosing the wrong validation tool leads a team to test the wrong assumptions, dangerously masking the true risks of the project. Let's look at technical risk first. Tracer bullets allow engineers to test if a representative technical path works in the real system. For example, imagine you are building an AI resume assistant. We map the required system architecture. A user uploads a file, it hits the backend, routes to a language model, saves to the database, and pushes feedback to the UI. A tracer bullet builds a thin end-to-end path through this architecture instead of the whole application. This provides concrete evidence that the integrations, architecture, and technical direction function together. While this secures the engineering foundation, it offers no proof that real people actually want an AI resume assistant. That brings us to testing the market with a minimum viable product. An MVP is a usable version of a product that provides enough real value to be used by target users. Product viability requires enough utility to test critical product assumptions. If users cannot derive real value from the experience, you won't learn if they will ever return or pay. This branch highlights the real user evidence stream. For the resume assistant, users upload a resume to get basic AI feedback. You release it to see what happens. Do users complete the workflow? Find it valuable? Will they pay? You track numeric behavioral data. This stream successfully validates market demand, customer hypotheses, and business viability. While an MVP provides essential real user evidence, it does not guarantee that the underlying technology is stable or scalable long-term. You are balancing two highly specific types of evidence: system execution data and real user behavioral data. Over-indexing on a tracer bullet risks dedicating immense resources to a flawless architecture for a product no one actually wants. Over-indexing on an MVP risks selling a compelling promise that your technical architecture cannot actually deliver. Teams often try to dodge this tension by broadly agreeing to build a prototype, hoping a generic test will magically validate both market and technical risks at once. It rarely does. As complex products evolve, teams will eventually need to investigate both technical and product risks independently. Project survival requires deploying the exact validation tool that corresponds to the team's highest current vulnerability. Product development does not have to follow a rigid sequence, like building a tracer bullet first and an MVP second. The correct order depends entirely on where the project's highest degree of uncertainty lies. Starting with the highest risk. If the biggest unknown is a market assumption, like willingness to pay, the team starts with an MVP. Conversely, when the highest risk is technical, like processing massive files, the team starts with a tracer bullet. Effective resource allocation follows the shifting risks of the project. Product managers and engineers can stop arguing over whether they should build an MVP or a tracer bullet. Start by asking one primary framing question: what assumption would be most damaging to the company if it were wrong? This layout shows the follow-up. What exact evidence would actually reduce that specific uncertainty? Different risks require completely different types of evidence, and different evidence requires completely different validation strategies. Engineering discipline relies on relentlessly identifying uncertainty and securing the exact evidence needed to eliminate it.